All right, so hope you enjoyed the lunch. Let's get back and proceed to our next talk. And delighted to introduce our next speaker, Professor Assaf Schuster from Technion, Israel Institute of Technology. By the way, my name is Ilya and I'm also from Israel, representing here the Israeli branch of Red Hat and taking care of our academic activities. Assaf is an ACM fellow and an IEEE fellow with many years of experience in diverse fields, from computer systems to distributed computing to machine learning, and he is going to present us a project which involves a little bit of everything, every of the areas in which Assaf specializes. So Assaf, I'm happy to welcome you on stage.
Okay. Thank you very much, Ilya. Thank you very much for inviting me here to speak. It's a great event, and I'm very happy to be part of it. I'll talk today about Spot operating system, or SpotOS. This is a joint project between Red Hat Israel with a set of a great team of engineers: Ilya Kolchinsky, Idan Levy, Orit Wasserman, Gabi Ben Hanok, Josh Salomon, and Avishai Treger, and myself from the Technion. And a large set, like dozens of students from the Technion who participate in projects to build parts of SpotOS. So let's start from motivation. And the first question that we ask ourselves is, does the cloud, as we know it today, public clouds, meet its promises? Let's consider several promises. For instance, auto-scaling, it gets a grade V. It is good, it's working, it's auto-scale. And there are other promises like security that may be arguable, but there are three promises that are definitely very, very far from being met by current clouds. Let's talk about vendor locking. We've been promised that it will be easy to move application from one vendor cloud to another. It's very hard to do today. We know that if we can do that, vendors will not be competing, and we have a lot of indications today that vendors coordinate their prices and the raises in their prices. So this is somewhere where the cloud did not meet its promise. Another promise that we were made is that the vendors, the cloud vendors, are going to get very large discounts because they buy their hardware in very large quantities, and that this discount is going to propagate all the way to the users. Well, no, nothing of this sort happens. On the contrary, if you buy cloud resources today, you pay something like an order of mag more than the amount that you pay if you buy your own hardware. And last but not least, we were told that submitting application to the cloud, they are going to run automatically, optimally, and so on. Unfortunately, the clouds, in order to run on the cloud, you need to optimize a three-dimensional configuration space, a very large configuration space. You want to minimize your cost, you want to maximize your performance, and you want to have your availability. And this three-dimensional configuration space is very hard to come by with. And the cloud providers do nothing to give us tools in order to optimize our applications when they are sent to run all the clouds. In fact, they have the contrary motivation. They have the reverse motivation because today, if you run your application on the cloud, you probably will be paying more in order to make sure that you meet your performance and availability requirements, but you lose a lot of money because of that. So let's talk about a little bit about issues, specific issues for cloud users. The user would like to optimize the number of the amount of money that it pays. So it needs to have intimate knowledge of CPU, of accelerators, of memory, both in her own application that it sends for execution, and the offering that it gets from the cloud provider. So most companies today that use the cloud intensively, they actually hire cloud experts. And those cloud experts help the companies in order to optimize the use of the cloud, which means that A, they need to pay a lot for those cloud experts, and second, those cloud experts sometimes make mistakes, and they cannot meet the optimization that we hoped to get from the cloud. There's also the problem of information of instance availability and prices, as those experts do not have online, do not get on the fly. And also the little problem that if you have an application or a service running for a long time, then you would like to optimize it at any point in time and to apply changes, like the cost changes, the cost of certain offering of the cloud, of certain instances change, the instance types change over time. You want to dynamically optimize your price, and you cannot do that today. So one way that you can optimize the cost that you pay is by using spot instances. What are spot instances? So the only way the cloud providers today can get ready for peak demand times is to save some spare resources on the side. And mind you, I'm not talking about small hardware. I'm talking about tens of percentage points of the total volume of the cloud resources. So what does the provider do? It lets you rent these resources with a very high discount, about 70 to 90% discount, if you're willing to guarantee that when the cloud interrupts you, you will evacuate your application and give back the instance that you are now working on. And if you try to use these spot instances, you run into a lot of trouble. For instance, suppose you want the cloud to restart your application once the spot instance becomes available again, so you choose to run it in hibernate mode. In AWS, this means that you have to restrict your state, the state of your application, to 100 gigabytes, and you can only select certain very expensive instances to do that, and there are other restrictions. So using spot instances today, many people try to do it, but they run into a lot of restriction and eventually give up and again pay a lot of money. So once I talked about the motivation, here's the vision. The vision is to have SpotOS, an operating system for the cloud, which will be a heaven. Will get you better prices than spot instances, will get you better availability than any instance on the cloud. We get you better performance, and it will be very easy for a user to communicate with it. It does not need to be an expert on systems, on computer systems. In fact, it should be as easy as sending an application to your laptop and waiting for it to complete its computation. And again, if I promise you all this, the question is how I'm going to do that. And before I tell you how, I want to restrict the focus of this talk. It's going to talk only about Spot instances in order to, again, be more focused within this talk. So an instance, when I say instance, I'm talking about Spot instance, and when I say interrupt, I'm talking about a request from the cloud to evacuate the Spot instance you're currently working on. So here's SpotOS. SpotOS is a distributed abstraction, or an abstraction layer, which sits between the user and the cloud. It gets requests for execution from the users, and it interacts with the cloud to rent more resources and to release them, and to also control all the instances that it currently has from the cloud. Under the hood, a lot of things are happening. Scheduling, migrations, allocations, optimizations, interactions, predictions, and so on and so forth. It's actually an operating system that helps you to interact with the cloud and to optimize the run of your application. And of course, if we already have an abstraction layer between the user and the cloud, why not have this abstraction layer communicate with many clouds and allow you to juggle between them? So this is also part of the vision. So what are the advantages of SpotOS? I actually summarized what I already said. We are going to optimize the configuration of resources for every application because the operating system knows about the application. It knows about the availability and the cost of resources from the cloud. It can optimize the configuration. But it can do even more. It can optimize the overall set of applications that are currently run by it. It can do so dynamically when offerings change. It can optimize over a very large configuration space. In fact, the configuration space on which it optimizes is larger than what you have today possible from the cloud. Then you have high availability. High availability means that the apps keep working even though they are interrupted from the cloud, and the operating system will try to minimize the transition time after a failure, after an interruption or a failure. You also have interaction complexity, which is reduced to minimal. As I said, it should be as easy as sending an application to be executed on your laptop. In terms of performance, the operating system tries to match resources to the application so it maximizes your performance, and it also can optimize locality across pools and regions in order to optimize, in order to bring your application to work in locality with data gravity and the application gravity. And finally, it can be a cross-platform. It is going to be a cross-platform. It is going to work across cloud vendors. Just to give you an example, what I'm talking about in terms of cloud, configuration space, consider an instance, and here we have 3 applications that can use the same instance. These applications can be packed together and be chosen to be with resource, complementary resource requirements. Because they have complementary resource requirements, one needs more memory, another needs the accelerator, another needs more CPU, and so on. They can be packed together much more efficiently. And this you cannot do today on Spot instances. Here's another configuration, example for configuration which you cannot do today. You have an application X, and you have a very large state, which is drawn here in red, and instead of, so what you do today, you rent a very large memory instance in order to run your application, while it would be much better price to rent simply 2 standard instances and run on those 2 instances. The problem is that you need to split your state into 2. Half runs on the first instance and half runs on the second instance. This is a configuration that you don't have today on the cloud, and SpotOS will enable it. All right, so just let me summarize very high-level challenges that you have when coming to build such an operating system. First, the whole thing is a moving target. Prices change, instance types change, everything changes from one day to another. And you must build, you must design the whole thing in such a generic way to accommodate the shifts that appear over time. Second, there are a lot of trade-offs. I told you about the 3-dimensional optimization space, but there are many, many trade-offs that are involved in building this creature, which we call SpotOS. And you need to resort to traditional algorithmic computing science and all kinds of methods in order to solve those optimizations, the dynamicity, the trade-offs, everything that you find. And there's also a lot of performance optimizations that are needed, and we draw from distributed computing, those distributed systems literature in order to solve them. And finally, in order to understand what is going on, you sometimes want to predict what will happen next. You want to predict the behavior of your application for the next 30 minutes, the next hour or so, in order to understand how much resources you want to rent from the cloud. You also want to predict the behavior of the cloud itself. Is it going to interrupt my Spot instance or not? So in order to predict, you need a model. You need to learn how the cloud behaves and be able to predict what it's going to do. You want to predict what your application is going to do next. Is it going to all of a sudden want a lot of CPUs? You can predict that if you follow this application previously or similar applications and gathered a lot of data, and an operating system can do that. Usual operating systems, the common operating systems that we talk about, do that too. So why not do the same on the cloud? So the solution space from which we draw our solutions here is the machine learning and AI space, new technologies that are coming in, really very powerful. Okay, so let's talk a little bit about designing SpotOS. How are we going to design this creature? The first thing that we need is a cloud cost optimizer. Okay? This is a module that gets its input from the cloud, costs and instance availability. It gets the demand, the applications that want to run currently on the cloud, and it computes a perfect match, perfect by means of minimal cost match between the demand, the resource demands of the application and the current availability and cost that come from the cloud. The only problem for implementing it is that when you look at Spot instance types or instance types on the cloud, you see that there are thousands of them for every region, and the applications themselves that want to run on the SpotOS, they may be tens or hundreds or thousands of them. So the optimization, and each application can have many components, maybe dozens of components. So the optimization should run on a very, very large configuration space. It is super exponential in the input, in the size of the input, as the size of the input is thousands. There's no way we can actually solve it with deterministic tools. So again, we resort to all kinds of meta heuristics. This is how the CCO is built, the cloud cost optimizer is built. Again, from it draws the costs of instances and the instance availability from the cloud all the time in a dynamic fashion, and it gets as its input all the applications that want to run currently. And then all of these inputs come into this box. This box is built by advanced meta heuristic. For instance, here a local search is drawn, but you can have any other meta heuristic for solving a very, very hard optimization problem that needs to solve on input of size of thousands. And inside it has to take a lot of parameters into account. For instance, the application are multi-component, the super exponential complexity, the multiple cloud provider, multiple performance objectives that we need to have. I already told you about it, multiple instance types, region, other parameters, whatever have you. So this is a huge thing to solve the optimization in this space, but spoiler, we already have it running on AWS, and we are working to have it run on Azure. So the next component that you need for SpotOS is the learning module. I told you that we would like to predict, to forecast the demand of the applications for resources in order to be able to rent resources from the cloud before we'll actually need them. And I told you that we want to study the behavior of the cloud in order to maybe create a model that will be able to predict when we'll have interrupts or when we'll have shortage of instances and so on. So this is the task of the learning module, which we call ML. It is learning. We had a lot of trouble in starting it because we need data in order to learn, and it was very hard to obtain data from users, but eventually we were able to do that, and this module is in the works. Then we have something that coordinates all the work of this SpotOS thing. We call it a global manager, or the golem. The global manager gets all the information of monitoring the application and demand from the learning module and calls the CCO. So the CCO will provide it with configurations that are optimal for the demand and so on. The golem is what manages the whole thing. Then we need to have an application migrator, because we cannot talk about a high availability. We cannot talk about a situation when an application is interrupted, is running on a Spot instance, is interrupted, and then it starts again on another instance, unless we have an application migrator that is currently working. Now, mind you, I've been working on application migration, on thread migration and stuff many, many years ago, and when I came to consider this module, I said, okay, so bring me one. I was sure that there's something already prepared. Well, it's not that easy. We are working on it. It will work eventually. Finally, I told you that we would like to optimize over the space of memory and states, and we would like to be able to distribute the state of a very large application on several machines. This is a task of the external distributed memory module. The external distributed memory module can help you take a state which is too big, too large to fit in a certain instance, and distribute part of it outside with minimal performance hit. All right, so while working on such a large vision, on the way you get to have a lot of partial results, each of which is worthy to become a product. So here's one, the cloud cost optimizer. You would like users of the cloud, to have the possibility to to send their requests, to send their demands of resources, and to get back from the cloud cost optimizer an advice how to use it and which resources to rent. The second is the learning module. Of course, you'd like to learn new applications. Sometimes users do not know the resources that an application require, and they need some module to advise them on that. This is a learning module. The third is the application migrator, as I already said. And the last is the external distributed memory. Again, suppose you do not want to rent a very large instance because it costs a lot of money and you have a lot of space. Why not rent 2 or 3 or several standard instances instead? You'll pay much less money, and the EDM will help you distribute the state with minimal performance hit. So I'll skip that. Whoop. Whoa. I'll skip that and go directly to the summary slide. SpotOS is necessary stage in cloud evolution. It transforms the cloud into a friendly space for users, and so on and so forth. I already talked about all this. We hope to be able to move forward as fast as possible.
All right, so let's take a look at the questions, and there are a lot of questions coming in, so I apologize in advance for not being able to answer all of them, so please feel free to approach Assaf during the break or afterwards with the questions that we will not have time for. So let's start. So Assaf, what is the average lifetime of a Spot instance before it gets interrupted?
Again, what is it?
The average lifetime of a Spot instance before it gets interrupted.
This depends on the Spot instances themselves. There is some information about that that the cloud gives you. The cloud actually is willing to give you the number of the average number of the time that it took for an interrupt for a certain instant type over the last 3 months. This is the information that it gives you. It's not enough information to learn and to do predictions. We are trying to get other types of information, but that's what there is.
All right, let's move to the next question. So, how does SpotOS handle low compliance issues, such as GDPR? That is there a control over where the data ends up being processed and stored?
I guess this is something that will have to be handled after the prototype is developed and works.
Yeah, now, that's an interesting one. What do cloud vendors think about SpotOS?
I do not consult them. I talked with Red Hat people, and all of the Red Hat people that I talked with are very happy with it.
What will happen if the cloud does not provide enough free instances to continue fully serving the application?
This should not happen. By cloud providers, they should be able to, you should be able to to do any top demand or peak demand point in time. However, it might be that there will not be sufficient number of spot instances, and then you'll have to resort to on-demand instances and stuff like that.
All right, and a couple last questions, and again, I apologize for all the questions we will not be able to accept right now. Can you compare SpotOS to ManageIQ?
ManageIQ?
Yeah.
In my slide of competitors, I don't have ManageIQ, so I'm sorry, I cannot.
All right, and is SpotOS deployed and running anywhere, or is it still a concept?
No, it's. I think I tried to give you a feeling of where it stands. All of the modules that I was talking about, there are teams of students working very hard to in open source. Working very hard to construct, and we are just starting an integration phase where we are trying to run them together. Some run with only one cloud provider, some we have already started to run with 2 cloud providers. It's in the works. It will not happen tomorrow, but I have big hopes that in the short future.
All right, and one last question. Is there a chance or a plan to share the models and datasets used for training for more collaboration in an open source way?
Yes, there is, and again, I tried to say that all these modules will become available as independent products of independent open source products, and we will make them available to everybody. They are already available. I mean, all of them are worked on in an open source fashion.
Great. So let's thank our speaker again.
Thank you.